Hello everyone, Mr. Hasty here. Today we're going to continue our discussion in Chapter 10 talking about music. Music's one of the most common uses of sound waves, and it's very interesting because pretty much everyone likes some form of music. So let's talk about what is music. Now, when you define something that's artistic in nature, the definition is going to be a little vague because there's a lot of interpretation. A lot of people disagree about what exactly constitutes particular art forms. So one thing that is true about music is we know that it is organized sound for an artistic purpose. You're looking to make people feel something when you create a song, either happy or sad or pumped up or whatever it is. So, a few key points. It's organized. Something can sound good without being organized. Just the sounds that naturally occur during a forest, those are a conglomeration of sounds, and they might be pleasing, but it's not organized. And sounds can be organized without being for an artistic purpose. An example would be talking. When I'm talking right now, it's not for an artistic purpose. It is for a purpose, though. Now, a lot of music comes down to when we use different instruments, the natural frequencies of different material and resonance. So, let's review those concepts. People make guitar strings out of different materials. Some guitar strings are made of metal, and some are made of nylon. And the reason why is because those two different substances have different natural frequencies. They will generate slightly different waves, even though they make the same notes, because they're different materials. They will also, when you have a note, it triggers resonance. A common example of this is in the body of an acoustic guitar. Let me draw a guitar here. I'm bad at drawing, but this is actually not so bad for me. That's pretty good. Pretty good for me. So in a guitar, you have a hole in the middle, and the strings go over that hole. And as the strings vibrate, it moves the air around inside that body, which resonates the air and resonates the structure of the guitar, helping to create a more pleasing sound. So, instruments make use of natural frequencies and resonance to create music. So, this brings up a question as to why do different instruments sound different? So, we're going to define what we call the sound quality. The sound quality is the differences between two sounds of the same pitch, which is frequency. I'll just use the word frequency here. And loudness. So if a guitar plays a C note and a person sings a C note and a piano plays a C note, all those sound different. And if you listen to enough music, you can pick out, oh, that's piano, oh, that's guitar, oh, that's a person's voice. One of the things that contribute to these types of sound quality are what are called overtones. So overtones are vibrations whose frequencies are multiples of the fundamental frequency. Now let's talk about what that means. So, when you pluck a guitar string, the large wave that is created is called the fundamental wave. And due to resonance, you're going to get some other frequencies that are maybe, they follow the same pattern, they hit at the same points, but there are multiple, essentially like a quicker version of that wave. And that creates overtone qualities, and those overtone qualities relate to different sound qualities. Now, we call sound quality in the world of music the timbre. Looks like you're spelling timbre, but the timbre of the instrument. That's why woodwinds and brass instruments sound different. So now we're going to take a second. We're going to talk about different types of musical instruments. And so there are, for our purposes, going to be 3 broad categories. Strings are instruments like guitars and violins, basses, all those instruments, and they are typically played by plucking or using a bow, which helps to vibrate. A bow is what you use on a violin. Plucking or using a bow across a string. Now, these instruments use heavy use, anything that's acoustic, not an electric guitar, an electric bass guitar, not those, but violins, cellos, acoustic guitars, they use resonators. Resonators are chambers of air that resonate with the strings. So this is what's the hollow inside body of an instrument is called the resonator. Now, there's a variety of different types of string instruments, and they typically all fall into 2 categories. Plucked, like your standard guitar, bass, things like that, ukulele, or bow, which is a violin or fiddle, cellos, violas, those type of things. Now, regardless of the type, they're either going to use a resonator or they're going to use a set of electric pickups like an electric guitar to amplify the sound. They need one of those 2 things because the sound of a vibrating string is actually fairly soft and they need something to amplify it. So woodwinds and brass instrument, this would be like saxophone, flute, clarinet, trombone, trumpet, tuba, all those, bagpipes if you want. Basically, they are worked by vibrating a column of air. And that air is the air that is moving through the instrument. Now, a lot of these instruments, their qualities, their sound quality is based on the materials they're made out of. But they all vibrate a column of air. So let's quickly talk about it. Flutes, oboes, flutes, piccolos, and instruments like that, we can visualize them sideways. There's a hole, and you blow air across that, which vibrates the air inside the tube. Now, the keys on a flute change the length and size of the inside, which is called the resonator. The inside of the instrument is the resonator. So you're changing the size of the resonator by deciding where the air comes out. Now, in more traditional woodwind and reed instruments, saxophones, clarinets, oboes, you have a piece and then you have a reed, and you will create vibration along that reed by blowing air across it. Similar thing, you press the keys, that changes your column of air. And finally, brass instrument, whether it's a trombone, which slides, or something with valves like a trumpet, you have a mouthpiece, and the way you put your lips on the mouthpiece, you make a sound with your mouth, and as the air goes in, it's vibrating already. What you're doing when you press those valves and move that slide is you're changing the length of the column of the air. So as the air goes into the trumpet, if you press a key, what you're really doing is changing the length that the air needs to travel. Finally, percussion. There's 2 broad categories of percussion. Percussion instruments are instruments that vibrate from striking. It's actually a very broad category. Most commonly, people think of drums, but cymbals or even the triangle is another form, as well as a xylophone, which is little blocks of wood or blocks of metal that you hit. Each of those works slightly differently, but basically, let's talk about things like xylophones, triangles, and cymbals. You have a material, whether it's the key of a xylophone or a cymbal, that when you hit it, it vibrates. And that vibration creates the sound that we hear. That one's a little more straightforward. A drum is an object with a drum head attached to the top, and inside that drum is air. So when you strike the head of this, it moves a column of air and creates the sound. Now, most drums that we're familiar with have one tone or pitch associated with them as you hit the top of the drum, but there are instruments that are designed basically to be differing levels of tightness as you go around them, like steel drums in Caribbean music that are shaped like this. Basically, where you hit the drum at dictates what kind of pitch you're going to get. And so all of these different instruments can be modeled using the same knowledge of sound and sound waves. So as a real quick example, there's something called Chrome Music Lab. And basically the way it works is you can just click on a square and make it a note or not make it a note. Down at the bottom here with the triangles and circles is a drum set. And you can change what type of drum you're hearing. In that you can change what type of tone you're hearing. So just as an example, I created this. It's not great. It's just like a thing I put together real quick. But you can hear, let's go ahead and listen to it as strings and a standard drum kit. And we can see how the notes correspond. This note is at a particular frequency. This note's at a particular frequency, right? Now, the volume can be adjusted by just raising and lowering your volume. That controls amplitude. But let's change the sound quality by changing let's go with a woodwind and a conga drum and see how it sounds different. So last couple, let's change it to a weird combo. Let's go marimba, which is like a xylophone, and blocks. And as a last thing, let's play with the tempo. The tempo is the speed at which it's played. So let's play that at 200, just see what that's like. Quick example of how those different factors play into actual sound. Now, this is actually a really fun thing to play around with. It's just, if you Google Music Lab Chrome, this will pop up, and it's very, very easy to use. And it's not real complicated. You can't do a whole lot with it, but it's fun to play around with. All right, and that will be the end of our lesson on music. I hope you guys enjoyed it. Next time we'll be discussing other uses of sound, and I'll see you then.